So, when you're calculating resistance, voltage, and current, you're going to use the formula you see at the top. That current is equal to voltage divided by resistance. The symbolic form of this equation is I equals V over R, where I is measured in amps. The symbol for that is A. Volts is measured, or the voltage is measured in volts. That's easy. And the symbol for it, V, or the unit is V. And resistance is measured in ohms. And the unit for that is the Greek letter omega. Omega, the last letter of the Greek alphabet. You'll see that as we go forward. You'll need this formula, so make sure you write it down, as well as all the parts. We're going to try and start off easy today, and you are going to calculate resistance in a series circuit. The formula for that is as follows, that R total, the total resistance, is equal to the resistance of the first resistor plus the resistance of the second resistor plus the resistance of the third resistor, and so on until there are no more resistors. Make sure you write down this formula. Make sure you pause the video here and write down each of these steps. If you write this down and use it every time you do one of these calculations, you'll always get it right. So step 1, calculate resistance for the whole circuit. I'll show you how to do that. Step 2, you'll calculate the current of the entire circuit using what's called Ohm's law. It's named after a guy, Ohms. And that's the I equals V over R, current equals voltage over resistance. Step 3, you're going to calculate the voltage for each individual resistor. I'll show you how to do that. And step 4, make sure the total voltage of the circuit matches the sum of voltages across all resistors. I'll show you how to do that. So, let's take an example to see how this works. You might see a question like, what is the voltage, also known as potential difference? Please make a note of that. Across the 3 ohm resistor in this circuit. Take a moment to draw out this diagram. Notice this symbol is the symbol for the power source. This might be a battery or an electric generator. In this case, it's giving 12 volts of 12. Its voltage is 12. We're going to see what the current is in it in a minute. This is the symbol for a resistor. This resistor has a resistance of 1 ohm. That's your Greek letter omega. This is another resistor over here. It's just a squiggly line. And its resistance is 3 ohms. And down here, this is a 2 ohm resistor. So we have 3 resistors in a series. They go all the way across in this orientation. We'll see other orientations later. All right, I'll turn this way for us. Now then, this is just a recreation of the problem you just saw. And what I've given you here is the formula for calculating total resistance for a circuit in series. RT equals R1 plus R2 plus R3 and so on. So all we're going to do is plug those in. RT equals 1 plus 2 plus 3. That's our 1, 2, and 3. I probably should have put them in order, but I didn't. You should when you do it. Just keep everything straight. Honestly, you don't even need the omega symbols here, the ohm symbol. You could have just done RT equals 1 plus 2 plus 3, or 1 plus 3 plus 2. And you get that a total resistance for this circuit is 6 ohms. That's its total resistance. So, if Ohm's law says I equals V over R, and the total voltage is 12 volts, and we found that the total resistance is a total resistance of 6 ohms, then we plug that into Ohm's law. The current can be found by taking the voltage, total voltage was 12, remember that's what we saw up here, and dividing it by the total resistance that we had just calculated up here. And we get that this circuit has a current of 2 amps, or amperes. It's a 2 amp circuit. Don't be stressed. This is not as bad as it looks. If we start with this right here, we've got our circuit, 12 volts total. We already knew that. And the amperage is 2 amps. These 2 amps in a series circuit are the same everywhere. 2 amps here, 2 amps here, and 2 amps here. If we have that information, since we have the amperage and the resistance, we can calculate the voltage drop or the potential difference for each resistor. So let's just take a look at this resistor first. If Ohm's law says that I equals V over R, then I, our current, 2, that we just calculated, equals the voltage. We don't know what the voltage is in this location. That's what we want to find out. What's the voltage here? How does the voltage change across this resistor? We can find that by doing V divided by 1. I'll work out that math real quick for you. Obviously, you could do this in a calculator, but if you multiply each side by 1, crosses out, 2 times 1 is 2. The voltage here is 2. Over here, we know that this is a 3 ohm resistor. This is R2, the second resistor, and that the current everywhere on this circuit is 2 amps. If I equals V over R up here, and our current is 2, we don't know the voltage at this location, but we know the resistance, 3. Do a little light algebra, multiply both sides by 3. That crosses out, leaving us with the voltage here is equal to 3 times 2, 6. Okay. Down here, we know the resistance is 2. That was told to us by the question. We calculated the amperage, the current, as 2 amps. So if I equals V over R, then I, the current, was 2, as it is everywhere on this series circuit. The voltage at this location we don't know. And then the resistance is 2. Again, a little simple algebra. 2, crosses out, V equals 4. And this is 4 volts. This up here was 6 volts. This over here, 2 volts. Right? Now the last step is if I've got 2 volts there, 6 volts there, and 4 volts there, let's just add them up to make sure they equal 12. That's our last step, step 4. So 2 plus 6 plus 4 equals 12 volts. This matches this, and we know we've done everything correctly. That's it. Now it's time for you to do some practice on your own. Good luck.